Hello students, welcome to second part of named reactions in organic chemistry. Here we can see about Wurtz reaction, Wurtz-Fittig reaction, Fittig reaction, Reimer Tiemann reaction and Kolbe reaction. So another 5 reactions we can discuss in this video. Before going to the topic, please subscribe my channel. Press the bell icon for notifications. Like, share among your friends and comment. Wurtz reaction is an organic chemical coupling reaction wherein sodium metal is reacted with two alkyl halides in dry ether medium to form a higher alkane along with a compound containing sodium and the halogen. The general form is 2Rx plus 2Na gives RR plus 2Na plus X minus. It can be observed from this equation that the two R groups are joined, yielding an alkane with a longer chain along with the sodium halide, where X is a halogen atom like chlorine, bromine or iodine. The mechanism involves a free radical species denoted by R, which is a part of halogen metal exchange. This mechanism is somewhat similar to the formation of Grignard reagents. The carbon-carbon bond is formed in a nucleophilic substitution reaction. In this reaction mechanism, which can be broken down into the following 3 steps. The first step, transfer of an electron from the metal to the halogen lead to the formation of an alkyl radical along with the metal halide. In the second step, a different sodium atom now donate a single electron to the alkyl radical leading to the formation of an alkyl anion. The third step involves the carbon belonging to the alkyl ion giving a nucleophilic nature proceeds to displace the halogen in the alkyl halide via an SN2 reaction and form a covalent bond with the carbon which was bonded with the halogen. The free radical mechanism for the Wurtz reaction involves the possibility of an alkene being produced as a side product. Thus, the required alkane product is formed in the Wurtz reaction mechanism. That is shown in this equation. Next, we can see about the limitations. Only symmetric alkanes can be synthesized via Wurtz reaction since a mixture of alkane products are formed when dissimilar alkanes are reacted. There exists a side reaction via which an alkene product is formed. Should be alkyl halide be bulky in nature, especially at the halogen end, there is a greater amount of alkene formed. Methane cannot be synthesized via Wurtz reaction since the product of an organic coupling reaction must have at least 2 carbon atoms. The Wurtz coupling method generally fails when tertiary alkyl halides are used. Next reaction is Wurtz-Fittig reaction. Reaction of aryl halide with alkyl halide and sodium metal with a dry ether present to yield substituted aromatic compound is called Wurtz-Fittig reaction. See, that is shown here. If the alkyl halide has more chemical reactivity than the aryl halide, it will form the carbon-sodium bond first and act as a nucleophile to the aryl halide, helping the reaction in forming asymmetrical products. If the reactants are formed with halogens of different periods, the difference in reactivity between alkyl halide and aryl halide can be achieved easily. There are 2 ways of mechanism of Wurtz-Fittig reaction. First one is the organo-alkali mechanism. When the aryl halide is reacted with the sodium metal, an intermediate organo-alkali compound is formed, which is followed by a nucleophilic attack of the alkyl halide as shown below. Thus, the required alkyl aryl is formed. Second one is the radical mechanism. Sodium atom acts as a moderator for the formation of alkyl radicals and aryl radicals. These alkyl and aryl radicals now combine to form a substituted aromatic compound. See, the mechanism is shown in the equation. The reaction can also be conducted using metals other than sodium, such as potassium, iron, copper and lithium. The reaction can also be called a coupling reaction. It requires an aprotic solvent as a reaction medium for which dry ether is quite suitable as it is a good non-polar aprotic solvent. The next one is Fittig reaction. In Fittig reaction, two aryl halides are coupled in the presence of sodium metal in dry ether or tetrahydrofuran to furnish biaryls. Biphenyl can also be prepared by Fittig method. That's also shown in this equation. The next reaction is Reimer Tiemann reaction. Reimer Tiemann reaction is a type of substitution reaction named after chemists called Reimer and Ferdinand Tiemann. The reaction is used for the orthoformylation of phenol, that C6H5OH. Phenol is treated with chloroform in the presence of sodium hydroxide. An aldehyde group is introduced at the ortho position of the benzene ring, leading to the formation of orthohydroxybenzaldehyde. Mechanism. The mechanism of Reimer Tiemann reaction begins with the deprotonation of chloroform by a strong base to form a chloroform carbanion. This chloroform carbanion quickly undergoes alpha elimination and give rise to dichlorocarbene, the principal reactive species for this reaction. Thus, the given phenol is converted into an orthohydroxybenzaldehyde using chloroform, a base and acid workup. It can be noted that the carbene is highly electron deficient due to the electron withdrawing nature of its two chlorine groups. This is why it is strongly attracted to the phenoxide, which is rich in electrons. The interaction favors orthoformylation of a selective nature. The reaction is Kolbe's reaction. Kolbe reaction, also known as Kolbe Schmitt reaction, is a type of addition reaction named after Hermann Kolbe and Rudolf Schmitt. When phenol is treated with sodium hydroxide, sodium phenoxide ion is generated. The phenoxide ion generator is more reactive than phenol towards electrophilic aromatic substitution reaction. Hence, it undergoes electrophilic substitution reaction with the carbon dioxide, which is a weak electrophile, orthohydroxybenzoic acid or salicylic acid is formed as the primary product. This reaction is popularly known as Kolbe's reaction. The equation is given: phenol reactive with carbon dioxide and sodium hydroxide form sodium phenoxide, which react with sulfuric acid and form orthohydroxybenzoic acid. When we examine the mechanism of Kolbe reaction, it can be classified as carboxylation chemical reaction. The reaction occurs when sodium phenoxide is allowed to absorb carbon dioxide and the resulting product is heated at a temperature of 125 degrees Celsius and a pressure over 100 atmospheres. An unstable intermediate is now formed. This unstable intermediate goes through a proton shift, leading to the formation of sodium salicylate. Now, this mixture is treated with sulfuric acid. The acidification of the mixture yields the salicylic acid that is given below. Thus, the required aromatic hydroxy acid, that is salicylic acid, is produced via Kolbe reaction. It can be observed that there is a nucleophilic addition of sodium phenoxide to carbon dioxide gas to form the salicylate in the mechanism. Dear friends, thank you for watching. Don't forget to leave a like and please subscribe my channel.